Pythagorean identities. In this video, we'll cover three Pythagorean identities. But the one that's most important, that gets used most often is this. Cos square theta plus sine square theta is equal to 1. Now, to prove this, you could either use a right triangle where the legs are A, B, and C. The legs are A and B, and the hypotenuse is C. Then we know A square plus B square is equal to C square. And if you divide both sides by C square, what you have on the left side of the equation is A square over C square plus B square over C square. And on the right side, C square over C square is just 1. Now, A over C, okay, so if I call this angle as theta, then A over C is sine theta. So that means this is sine theta square plus B over C is cos theta. But usually you don't see sine theta quantity square. Normally we write this as sine square theta plus cos, and this one is written as cos square theta. So that's the identity. Sine square plus cos square equals 1. I wrote cos square plus sine square equals 1 here, but it's the same thing. Now, there's one other way you can prove this. If you look at the unit circle, so on the unit circle, if theta is any angle, and if this is x comma y, then we define the trig functions, sine theta as the y coordinate and cos theta as the x coordinate. And notice that if it's a unit circle, this radius is 1. So what we know is that this altitude, if I drop a perpendicular from that point onto the x-axis, then this distance is x and this distance is y. And I can use the Pythagorean theorem to get this equation, x square plus y square equals 1, or x square is simply cos square theta and y square is sine square theta equals 1. So you can prove this identity either just by using the SOHCAHTOA right triangle or using the unit circle. Now, this is also trying to tell us something. If you have a circle whose center is at the origin and whose radius is r, then, and if this is the origin, then the equation of this circle is going to be, so if you take any point x comma y, then this, you know that this is r, so let me remove that, and this is x and that's y, then its equation is x square plus y square equals r square. So if you remember that, then you know the equation of unit circle is x square plus y square equals 1. So that's the proof of this identity, cos square theta plus sine square theta equals 1. Now let's look at that identity, cos square plus sine square equals 1. And if I divide both sides by cos square theta, then left side is cos square over cos square plus sine square over cos square, and the right side 1 over cos is secant. So 1 over cos square is secant square theta, because this is same as 1 over cos theta squared. Cos square over cos square is just 1, and sine square over cos square is tan square. So 1 plus tan square equals secant square theta. Now if you remember this, that's good, but definitely this is the most important one. You can always derive the other two simply by dividing both sides by cos square or sine square. So let's go ahead and rewrite that identity one more time, and this time we will divide both sides by sine square theta. Earlier we divided by cos square. Now the left side is cos square theta over sine square theta plus sine square theta over sine square theta, and the right side 1 over sine is cosecant, so this is cosecant square theta. Now cos over sine is the reciprocal of tan, because tan is sine over cos, so cos over sine is cot. So I have cot square theta plus 1 equals cosecant square theta. Now if I want it to look like this, 1 plus tan square, so let me rewrite this as 1 plus cot square equals cosecant square. So let's write this down. 1 plus cot square equals cosecant square theta. So these are the other two identities, other two Pythagorean identities. The first one was cos square plus sine square equals 1. So these are the three Pythagorean identities. The most important is this one, and the other two can be derived simply by dividing both sides by either cos square or sine square. And that's what I wanted to show in this video. There are a lot of identities in trigonometry, and we want to take them slowly, one at a time, and they have a lot of interdependencies as well. So be sure to remember at least this one, and then we'll cover more identities in subsequent videos. Thank you.